Hi everyone, and welcome to the Falco maintainer track. I'm Leonardo, and I'm here together with other maintainers to talk about Falco. So, first of all, what's Falco? You can think about Falco like the security camera for your cloud. Falco is the first ever cloud-native runtime security tool donated to the CNCF, and since the last year is a graduated project. It basically detects security threats and delivers alerts to your team. And how Falco works? Falco works by monitoring kernel or cloud events. For kernel events, it taps into the kernel using or a BPF probe or a kernel module, then send these events to the rule engine that match those events against a set of predefined rules. Those rules define anomalous behaviors and are needed to detect the threats or the security policy violation that can happen. Once a rules detect a malicious behavior, it immediately emits an alert. But there is more. There is more because Falco has a strong plugin system that allows you to grab data from other data sources, from the cloud. We have, for example, a plugin for the Kubernetes-native log, but we also have other plugins for other data sources like Okta or GitHub. And also, we have many options to deliver the output of Falco. Thanks to an ecosystem tool called the Falco Sidekick, Falco is capable to deliver those alerts to more than 50 destinations. You can send alerts to Slack, to assignments, to Kafka, to a database, and whatever. This is a very brief introduction of what is Falco. And now let's see today's agenda. Today we will talk about the latest feature in Falco. We will do an overview on the ecosystem with a focus on the Kubernetes-native log plugin. And we also show you some features that we are currently developing and that we are going to release very soon. Those features are the new container support implemented as a plugin, the Falco operator, and a new feature of the event generator. So, Luca, it's you.
Thank you. I'm here talking to you about what's new with Falco. So last time we talked, we were in Salt Lake City, for those of you who attended the Falco maintainer track, and we had some exciting news. So what's going on right now? So right now we are seeing, when we are here and we are at KubeCon and we ask people what they want out of Falco, everyone actually wants more things tailored to their use cases. And so, in the last few years, if you have noticed, we have made it so that you can make Falco your own. You can add integrations, you can add plugins, you can add everything. And our main duty as maintainers right now is making sure that the platform upon everything else is based, is stable, and is performing well. You've got images that you can deploy easily, and so forth. So we have focused on a lot of this over the last few months. For instance, we have been evolving our strategy regarding the container images. If you have been a long-time user of Falco, you might remember something. You might remember the good old big image that was the only image that you could have, more than 1 gigabyte big, which contained a lot of compilers and a lot of things that you didn't really need in all cases because they were needed to build the kernel module, because that was the only way to have Falco, or the legacy BPF probe, which also required to be compiled. Today, thanks to the new version of the eBPF probe, which uses Query, we can actually use a minimal image as the default image for Falco. And back in 2023, we started experimenting with Wolfie, the minimal undistro that has some advantages, and today we are shipping that as default, plus a lot of other images that you can choose to use depending on your use case. So what's the advantage, and why did we take our time to streamline the container images? First of all, smaller image size, so the image that you are running is smaller, and also many of you are required to run software composition analysis, such as Trivia or Gripe in your environment. environment. And this is going to alert you a lot about the potential CVEs and vulnerabilities. And you would need to fix that to maintain compliance. These images, such as Wolfie, have been designed to reduce the number of vulnerabilities detected by these tools. And so this means that if we were using the older Debian, you will find that you had, and you installed the Falco in November. Now it's complaining about 135 vulnerabilities that are mostly false positives. But if you were using the distroless or minimal image, that now is the default, you will have 1. So I hope we hope that we'll take some work back from the shoulders of DevOps engineers and security engineers that maintain Falco. Also, we have improved performance a lot by doing low-level optimization with, for example, we changed the default compiler where compiling with Clang and Zig, and we changed even the allocator at a lower level, so now we have up to 10% improvement in throughput for events, which doesn't sound like a lot, but some of you are running millions of events per second in your cluster, so that does really add to a noticeable improvement. Also, as usual, we are continuing to add fields and operators that allow you to write rules that are more expressive, do more things, more information about the containers. However, when we're talking about containers, there will be more exciting things that we'll be talking about in a minute. We have a line operator like many languages. We didn't have one before, and one day we noticed and we added, and some other modifications such as this one. Also, I will start by introducing some ecosystem projects, although later we'll talk a bit more in details about them. But we have a new entry in this. Many of you have asked, so how can I use Falco for supply chain security? Can I use this in my CI/CD pipelines? And we have people that actually built a project that does this, which is called Falco Actions. And it's an integration between Falco and GitHub Actions. So you can start Falco in your GitHub Action job and then have it record everything that happens and then analyze it for potentially suspicious events after the job is completed. It's very easy to run and to try, and it even has an analyzer step that can use capture files. Falco supports capture files, or even AI to try and figure out if something is wrong, on top of the Falco rules we all know and love. And we have also a new addition to the features of Falco Talon. People were very excited about the response engine of Falco. So you can actually, it's a response engine that's Kubernetes-native. You can tell when something happens, please do this action. And right now you can invoke GCP actions and use GCP Cloud Storage, because before they were more centered on AWS. And you can perform live captures. Falco supports captures, as I mentioned before, so you can essentially download what's happening at that specific time and analyze it offline. So this is a very exciting project. If you use it and you're a Go expert, please check it out and join us in maintaining it. So now, Aurélie will talk to us about a bit more about ecosystem projects and something very cool she's been working on.
Thank you. So now we will talk about what the ecosystem has done. Falco already provide plugins to read audit logs. We can do it from GKE and for EKS. And now you can do the same things with 2 new plugins for AKS and OVHcloud and MKS. We will talk about these 2 new plugins. So we have some prerequisites to follow for the AKS clusters. First, you have to create an Azure Event Hub. Then you have to enable Event Hub in your AKS clusters. in order to configure your clusters to ship the logs, and you have to create or to reuse an Azure Blob storage. So quickly, AKS clusters ship their audit log to an event hub, and it stores them to a blob storage. And then the Falco plugin just have to read from the event hub namespace and use the blob storage as a checkpoint store. In order to install and use it, you just have to execute the Falco CTL artifact install command, and you have to fill the Falco YAML file with this type of content. Don't forget to replace the event hub and the blob storage field. If you are interested, the source code and the blog posts are available. You have the QR code. And if you want to know a little more about the OVHcloud MKS plugin, so first you have to create a LDP, logs data platform. Then you have to create a data stream into it. You have to connect the MKS cluster to this data stream, and you have to retrieve the WebSocket URL in order to connect to it. So concretely, the audit log of MKS clusters are stored in a LDP data stream, and the Falco plugin connects to the LDP through the web socket. To install and use it, it's the same things. You have to execute Falco CTL command and to fill the Falco YAML file. Don't forget to replace the WebSocket LDP URL in the open parent field. And you can also install it through Helm. So you have to fill the values YAML file. All these files are in the README file and in some blog post. So if you are interested, you can find 2 blog posts and this source code of the plugin. And if you need another managed Kubernetes audit log collection, don't hesitate to contribute and to create another plugin. If I manage to do it for the OVHcloud plugin, everyone can too. Thank you. And now it's Jason will talk about what's cooking.
All right. Thanks. I'm Jason. I'm going to talk about what's happening in the updates for our container metadata support. I'm going to do a step back and give a bit of a refresher what we're trying to talk about here. So one of the fundamental things that Falco does is, as you know, collect telemetry and information from the kernel. But not only, like it also fetches data from the outside world for all those things that even the kernel is not fully aware of. One of these, for example, is the container information connecting to the container runtimes, but also speaking with the API server to get pod information, namespace, all sort of things. And then when a Falco alerts happens, like in the red snippet you see over there, you're going to have an enrichment section saying, hey, this event happened from that process, but also in that container for that image, from that registry, and so on and so forth. This has been one of the first features that we ever developed for Falco. It has been there since a while, and it's just one of the things that people can't give up on. So it's part of the core code of the project. So what is it that is not working for us? First off, the many points is maintainability in the sense of the code is pretty old, so it is working, but has been sitting there for a while, and it's becoming a cost for the community to follow on and keep updating that. Second point is Falco, for performance reasons, is historically written in C++, meaning that also this piece of code is written in C++. And over time, things are changing, we notice, but we didn't have native SDKs or clients to connect to the Docker container runtime or the CRY interface, so we had to maintain it and develop it in-house, which is a cost again. And also because we needed to make this as performant as possible, it's not super testable, and that has been a struggle for us. In terms of performance, this can't be synchronous. So imagine what happens. Falco is receiving events from the kernel. He notices that there's a new execution from a certain process. It will start looking up for the container information from the sockets that he finds in the system. Now, we can't wait for that information to arrive. It will be too late, right? We don't want to stall the event processing pipeline. And so we let the first few events go and wait for the result later on. That also means that we need to implement, and we did, some sort of locking mechanism with mutexes, which takes a considerable slice of the Falco CPU usage overall and impacts potential maximum throughput that the tool can sustain. This also impacts reliability in the sense that, given the model that I described, the first few events may come not enriched with information, and that is essentially a big issue. Can be an issue for everyone, but also especially for short-lived containers, in which cases maybe for those few milliseconds that we wait, we may lose the information entirely. So, okay, it was skipped, sorry. How is the plugin system helping us in this? The nature of the plugin system is multi-language, meaning that we can develop one in Go, and that's what we did. Nicely, the Go ecosystem provides a good set of SDKs and clients that we can use to connect to, all the container runtimes implementation that we support. But we can also do it multi-language in the plugin, meaning that we can have a slice written in C++ for the performance critical paths, and the Go side of the plugin, for the connection and integrations part. The new plugin, which is about to be released very soon, connects to the container created events, which happens before the container started events. And so now Falco knows about the container even before seeing the first system call being executed about that process. And the same goes for when the container stops. So that was funny to us, since we always had late problems. Now we know that the container dies even before we stopped processing all the syscalls about it. So we had to do some coordination. And the nice thing is that we were fully capable of doing feature parity. So this was a very good example of modularization of the project thanks to the plugin system initiative that started a couple years ago. And I need to say a big thank you to Federico in the specific, which is one of our core maintainers, which developed this all in the open with an open design and blueprint and bring it to completion. The outcome of this is a better time to data. So now it's basically instant. The moment you see the first clone or exec done by run C inside the container, that's already enriched with information, whereas in the past it could take up until a few milliseconds, and 100 we measure in worst case scenario. It's much easier for us to maintain and test, and we can collect many more contributors in that way as well, given that the Go code is more friendly. We were able to develop new Falco fields for container information, which can be used for developing Falco rules, and this is also quite more linear in terms of CPU usage. So now, let's say Falco will become even more performant in processing events. There's a couple breaking changes. The plugin system is not supported by the static builds with Muzzle, and so the container metadata will be lost there as well. Plus, for people using the new Falco exported metrics, there's going to be a couple numbers that are going to change the prefix, because now it adheres to the same prefix of the plugin system as well. And this is due to be released in 0.41, which it's supposed to happen in a couple of months, so stay tuned. And the promise we make as maintainers is to keep bundling this integration inside the Falco packages and images, so there will be no need for Falco CTL or any extra download at installation time, at least since Falco 1.0. So essentially, there will be no breaking change in terms of UX for whoever is installing Falco compared to today. You will probably just get the benefits plus those tiny breaking changes. And that's about it. I'm going to pass the microphone now to Aldo to learn about the Falco operator we're developing.
Thank you. Okay, the Falco operator, a Kubernetes-native Falco management. Well, why the Falco operator? Well, why not? No, just kidding, we really need it. So when running Falco with the Helm charts, we run quickly in limitations, and some of these limitations are that we have limited flexibility, and the reason is that Helm deploys Falco as a single instance type, meaning that if you need a daemon set, or after that you need a deployment, you will need another release, a Helm release, and that will be, let's say, a burden for many of us. And at the same time, we have problems with maintaining settings across clusters when we are deploying Falco in multiple clusters, meaning that updates are manually updates to values.yaml files, and that in time could cause drifties in the configuration. And also the artifact management. When deploying Falco with Helm, we have artifacts are deployed as a single instance with Falco, and if you need to update those artifacts, you will need to redeploy Falco itself. And this is, let's say, the reason why we need a new, let's say, Kubernetes-native management for Falco and its artifacts. Here we go, how it works. Well, we have there is the Falco operator, which is the main controller, which watches the Falco instances, which is a custom resource definition. And on that, we have the, let's say, only the configurations regarding Kubernetes, meaning pod template spec, deployment type, that could be a deployment or a daemon set. And it will not take care of, for the Falco configurations itself. When deploying Falco, it will inject an artifact operator, which is running as a sidecar. And the artifact operator, in fact, will take care to handle the artifact management. And how it does it, we have different kind of custom resources that are that models the different artifacts in Falco, like the rules files, configs, or the plugins, and it fetches them and makes them available to Falco in a volume mount that is shared between the two containers. Also, the Falco operator will allow multi-instance management. As I said before, with Helm, you will need different Helm releases, but here you will just need to deploy multiple Falco instances with different configurations, and the operator will take care to handle them, and it will not arise conflicts between them. So it is, let's say, a must for people that have different deployment of Falcos with different configurations, or maybe some for the node level security, like with syscalls, or others with plugins. So this will make things a lot easier. And here, let's see the flexible artifacts management. Well, I think this is huge because it will allow people to manage the artifacts differently from how we are doing right now. So meaning that artifacts management, their life cycle is separated from the one of the Falco deployment itself, so it will allow anyone to create, let's say, rules without needing to be, for example, an admin of the cluster. And at the same time, you can see that the artifact operator supports different sources for the artifacts. OCI registry, for example, for centralized and versions OCI artifacts. The Kubernetes config map, for example, for cluster managed configurations, or raw YAML. It will specify, it will allow to specify inline configurations into the artifacts. What does it mean? For example, let's say all of these sources can be specified in the same custom resource, meaning if you have the rules files, you can get the default rule set that the Falco security offers. And on top of that, if you need to change, let's say, a macro, a condition, or anything in the rules, then you can just set it in the inline configuration, and it will override the default rule set. And at the same time, the artifacts supports priorities. What does it mean? If there are two types of artifacts, then you can assign priorities, and the highest priority will override the one with the lowest priority. Again, this will allow people to override maybe rules that they don't have, they don't manage, or they are just getting them as is this from third parties. And also, the priority is also inside the artifacts. For example, if you have the rules that you are getting, the default rules, and you want to override something, the sub-priorities will say, okay, I need the config map that has the highest priority than the OCI artifact or from the inline configurations. And yep, and that's it from my side. And now I will leave the stage to Leo.
Thank you. And now the very latest news about the event generator. What's the event generator? The event generator is a tool that I created a couple of years ago to generate real kernel activity. I did this, why? Why? I did this just because we wanted to simulate real attack, real activity in the kernel, generating real events that the Falco can catch. It is needed because it's very useful to test if a rule works, but also to test the Falco engine itself. Indeed, the event generator as a mechanism to connect to Falco and check if the event generated by the event generator is caught by Falco. But what's the news? The news is that until now, all the action that the event generator could create were hard-coded, mostly in Go, into the tool. Now we are going to introduce a declarative way to generate tests. Basically, is a full flagged test suite when you can define, of course, the name, the rule that you are targeting, but you can create also a context for the event that you are going to generate. You can create a process tree, a process lineage with all the args and capabilities and names for each process. You can also create a resource like a client server that will be a bit difficult to implement in YAML. And you also can have step. Each step will trigger a syscall. And this is all activity that will be generated for real inside the kernel. There are a lot of more features that you can discover if you take a look to the event generator repository. One of these is, for example, that you can bind options from values from the resource to the arguments that will be passed to the syscalls. We have also a matrix to generate multiple events with different input values. And of course, it's not shown in this example. You can also define expected output values that the event generator will check once the test run. This will be released very soon. Okay, and now we are going to the end of this presentation, but before saying thank you, I want to invite you to join our community if you are not yet there. You can find us on the Falco channel on the Kubernetes Slack, and we also have a community calls every 2 weeks. I recommend you to join because you will find a lot of nice person like those. Thank you, everyone.